8.3, rational functions and their graphs. So rational function is just a function that's like a fraction and the graphs that go with them. You do not have to write this down, but here are 3 different types of rational functions and graphs that we could have. Now here's a continuous graph, meaning that if I were to draw out the graph, I would never have to pick up my pen. We're not going to be dealing with graphing those. We will be dealing with graphing these types of graphs. So in this first one, the graph of this, even though it's a fraction, looks like a straight line because these two would cancel each other out. So this would be like a restriction. Whenever you have a restriction, that means that there's a hole in the graph, and you have to represent that on your graph. This last graph I have, it looks like our typical rational functions or fractions with the x, except here instead of having a hole in my graph, I have an asymptote, meaning that x can never, ever, ever pass that line. So let's practice, shall we? First, you should write down the thinking process. If you look here, this is the first thinking process that we have for 8.4, and the second part is the same thinking process that we have from 8.2. So it's just really putting the two together and graphing. So make sure to write that down, because you can use your notes on quizzes. So starting with the problem, again, the first thing you should always do is factor. So when I look at top, I have an x minus 4, x plus 1. I'm looking for two numbers that multiply to get negative 4, but add to get negative 3. And then I have an x minus 4 on bottom. You should always, always, always state the restriction. So x minus 4 cannot be equal to 0. So when I have that, that would give me that x cannot equal 4. Now if I simplify this problem, I can cancel the x minus 4 on both top and bottom. Then I'm just left with the equation y equals x plus 1. Now this would be an example where I have a hole in my graph, because when I have the problem x plus 1, that's going to be a straight line. When in doubt, you can always use this and graph this in your graphing calculator to help you. But right now, at the point where x cannot equal 4, I'm going to make sure to include that on my graph. So if I were to put 4 into my equation, 5 would come out. So at the point 4, 5, I'm going to draw a hole, because it cannot be that number. So you have to make sure that whatever restriction you have, if it's a hole, you include that. So whenever you have a problem that just reduces to just an x, there's a hole in your problem. And then my y-intercept is this number right here. So I would go up 1, and this should create a straight line then. So if I have a straight line both on the left and right hand side. So I actually do not have anything for my vertical asymptote or my horizontal asymptote, because this problem is only dealing with a hole. However, I still have my y and my x-intercept. My y-intercept would be when x is 0, y is going to be 1. And if y is 0, then x is going to give me negative 1. And that would be it. Next problemo. Again, first thing you should do is factor. So I have x plus 1 on top. And on bottom, I could factor this to be x plus 2 and x plus 1. Now I'm going to state my restrictions. X cannot equal negative 2. It also cannot equal negative 1. So if you forgot how to do that process, remember you put each equation cannot equal 0 and solve. Now for this problem, I can cancel on both top and bottom. So my graph is going to be looking like this. Two things here. Now this is like a graph that we had in 8.2. So explaining the transformation, I'm going to have left 2. So that means my horizontal or my vertical asymptote is going to be x is equal at negative 2. Still going to have a horizontal asymptote at y equals 0. Now if I plug 0 into my equation for my x-intercept, I would get 1/2 out. But this is where you have to be very careful, because even though I have this problem, I'm still going to have a hole in my graph. So the hole is going to come where x is -1, because -1 is what's canceled out. So if I were to plug -1 into my simplified equation, 1 over -1 plus 2, that's going to give me 1 over 1. So this point around here, I plugged -1 into my equation, I got 1 out. There's going to be a hole there. So at -1, 1, I'm going to make sure to draw a hole. And my x-intercept is going to be not available because of my horizontal asymptote. So now I'm going to graph everything step by step. So first, I have my vertical asymptote at x equals -2, so that's up and down. My vertical asymptote at 0, and then I have a y-intercept at 0, 1/2. There's no flipping, so it'll look like this, but again, you have to make sure to include your hole. So my two graphs should be kitty corners of each other, diagonals. But you have to include the hole and the asymptotes. That's where these two numbers come from. Right now I want you to pause the video and attempt this one by yourself. This is like the problem that we first did it, so it's just going to have a hole in it. So again, first factor and go through the whole process. So you should have gotten the restriction that x cannot equal -1. And then if I simplify this, my simplified equation now becomes y equals x minus 1. So there's going to be a hole here. So to figure out where the hole is at, I plug in what x cannot equal into my equation. So -1 minus 1, that would give me -2. So my hole is going to be at -1, -2. So I'm going to write that into my equation right away. So draw your hole. So whenever you have just the equation, like a linear equation, there's not going to be any asymptotes, so I don't have to figure out what those are. However, you still have to figure out what your x and y intercepts are. So make sure to do that right now by yourself. And your 2 points should be at 0, -1, and at 1, 0. So now that I have enough points on my line, I draw my straight line. Do not go through your hole, because you have to make sure to represent that that is a spot where x cannot be. And that is all I have for you today. Have a wonderful evening.